I am understanding any virtual first time at today's video. I will teach you how you can make a IoT based home temperature humidity using DHT 11 sensor and node MCU in everywhere in home. So in a project, this is a project based on DHT 11 sensor and node MCU. So node MCU powered by a power bank and node MCU is connected to the DHT sensor via ground to the node MCU ground to the ground of DHT 11 sensor. DHT 11 needs 5 volt via V in pin of the node MCU. DHT sensor output pin is connected to digital pin 2 of the node MCU, and node MCU contain Wi-Fi which will set my DB or my Wi-Fi router. You can use home hotspot or any cell phone hotspot to provide internet. If I search the IP address on the cell phone 192.168.1.102 in my your case it may be different, because first time when you build a project you need to power in this project via your laptop, open a serial monitor, set to 11,500 baud rate, and then you can get the restart this serial monitor. The IP address, you can copy this IP address, and this IP address not change the anytime. You can use in top note and then use later. Now if I restart this, load this ESP8266 DH web server. Right now I am sitting in room. This setup is sitting in room 22 degrees Celsius, 36 degree percent humidity, and you can put this thing all over in your home and monitor the room temperature, your room temperature or anything else. If you are sitting here, for example, if you turn on the heater in the room in the winter season, and some reason you can go outside your home and you will monitor your room heating temperature via your cell phone, via this node MCU and this DHT 11 sensor, temperature as well as humidity, both at same time. But that case you need internet connections with both devices, like the internet from this node MCU, also a cell phone or tab or laptop. Which laptop you can log in this IP address. And right now there is a super little setup. Let me explain you. Node MCU ESP8266 use ground is that to do a node this ground of DHT11. You can use DHT22, DHT11 or any variant of DHT temperatures and their sensors. And Win or 3.3 board, you can give 5 volt 3.3 with the sensor. Right now I give V in mini 5 volt give with this 5 volt of this sensor, DHT11 sensor, and this sensor also need to ground with node MCU, and this sensor outputting that signal which is fed to a digital pin 1, and this will connect a table to the power line of the power bank. And this video is anyway, I'm next video very soon. I later explain the code in the video. So in this code of the first import libraries, go to the libraries, include H library, include Wi-Fi ESP8266.h library, include H library, include ESP asynchronous TCP H library, include ESP asynchronous web server .h library, Adafruit sensor .h library, DHT.h library. This library include, and then put my password. Put the password here. My Wi-Fi router or SSD router, which is, or you can put your SSD router password, SSD here and password here. Constant tractor SSD here, constant tractor password. There we can put your password.
define DHT pin 5. So DHT pin number 1 in this case. Define pin number 5, but reality in word with a pin number digital pin number 1. There defined types of sensor. Here we defined the defined sensors. So there are basically 3 types of sensor: DHT11, DHT22, and DHT21. So there are 3 types of sensors defined. Right now it will work with these 3 sensors. So it will work single at a time with single sensor. So you can change. There are 2 defined like 22 or 21. DHT22 or DHT22 are blocked by double slash. So right now software cannot read these 2 sensors. It will need digital 11 sensor, which is my case. In my case is I use the digital 11. Digital 22 or digital 21 is not using. So if you test your sensors DHT22, then you can block DHT11 or DHT21. If you are using DHT21, then you can block DHT22 and DHT11 by putting a double slash. At a time, only one sensor will be what? DHT pin, DHT type. Let's put 2 variables. Float. Both variable is a float type. Float data type. T H variables equals 0 0. Initially it's 0. A synchronous web server starts 80 using port 80. Unregistered launch previous mills equals 0. Will start command will store last time DHT versus update. Constant launch interval equals 1000. Constant chart index HTML program equals R dot type HTML. So it stores the web page. Which web page it installs the data. Style this starts meta name view post tone, and there's put a web notation, which notation, or web page notation, which notation it will upload the data. Display block, insta block, matin OPX auto, and this address, which address can send the data. It will send the data on these addresses. These are all the address right now. As to font size, there's a size dimension 3.0.3.0 REPM. Unit font size 1.2 REM. DHT labs font size 1.5 REM. Vertical line mid position pending bottom 15 style add body there S2 ESP86 DHT web server. This less data than H2. There are addresses which addresses will send the data and send data, and there's some conditions like condition, strain process, constant certain and well variable, shear plane variable. If variable equal then double equals then temperature runs setting strain T, else if variable equal humidity return strain H, return strain. And there's some white setup which using white setup 11,500 baud rate for serial communication, DHT billion, Wi-Fi billion, SSD password, serial print connection to Wi-Fi for connecting, while Wi-Fi status not equal to well connected for Wi-Fi connection delay under 1000 milliseconds serial print if not detected, serial print local IP, which local IP then put into your computer or any other device to access. Print ESP local IP server on asynchronous web server fast it send it data than less data than send P200 that's HTML index and HTML process server on temperature HTTP that asynchronous web request, and there's server on temperature that HTTP internet. So it repeats 3 more times and comes to a white loop. And if the turn mills equals mills, if turn mills that minus previous mills greater than equal the iterative previous mills equals turn mills new equals DHT read temperature. If instance new serial print fail to read DHT, so if instance new serial print if not detected, if the DHT is not detected, it will print serial print fail to read for DHT sensor, else T equals new serial print T read immunity float new H equals DHT read immunity. If immunity instance new serial print fail to read DHT sensor, else H new H serial print H.